Tenakutu Katwa. Hello, my name is Syed Amir Hossein Maghul and I'm presenting this work on behalf of myself and my colleagues Mitra Humolja, Tain Molota and Mark Schnabel. We are based at Victoria University of Wellington in New Zealand. This paper was initiated as a part of a research project that aims to study the impact interior design has on users' emotions. We are utilizing knowledge and methods at the intersection of architecture, environmental psychology, and systems science to investigate how automatic physiological responses as a correlate of emotion could be used to inform architecture. In the 1930s, the concept of general system theory was introduced to formulate a field of science that can be applied to systems of all types. This topic was later followed by the works of Wiener, who coined the word cybernetics. We have applied the theory of cybernetics to design a VR experience that adapts itself to users' predefined emotional needs. Much like the second-order cybernetics system, our simulations have an actuator, a sensor, and an adaptation mechanism whereby participants' real-time biofeedback is interpreted and loops back into the simulation to moderate the user experience. We found two projects that have used somehow similar approaches to design systems that feed back human emotional responses to regulate the behavior of the system. Schnabel and colleagues have developed a prototype which maps a single occupant's skin respiration to the size and the form of a structure. Moreover, Yamaguchi has designed an interactive social media puppetry based on second-order cybernetics. That project seeks to facilitate self-reflection by using a closed-loop system that automatically reacts to the motion. We have designed a dynamic audiovisual virtual environment that has parameterized design features. The virtual environment can morph between different values for each feature based on the interaction between the sensor, the actuator, and the adaptation mechanism. The actuator in our system controls the state for 5 design features. We selected these features based on the existing literature in environmental psychology. For color feature, red color is expected to increase emotional arousal in contrast to the blue color which is expected to decrease emotional arousal. Also, rectilinear space is anticipated to increase stress level versus curvilinear space which is expected to decrease the stress level. Moreover, the size of a space is also expected to influence the stress level. By changing the level of biophilic, we expect the system will evoke different emotional arousal levels. And finally, for sound, higher bitrate of background sound is expected to increase emotional arousal. In contrast, a lower bitrate of background sound is expected to decrease emotional arousal. In this project, we use a JSR device as a sensor to record electrodermal activities during exposure to virtual environments. We applied a series of calculations on raw JSR data to detect the tendency in emotional arousal of the users. The self-regulating part changes the state for each feature based on the real-time data collected. The system will balance the detected trends in the stress level to maintain the predefined emotional goal. For instance, for a detected positive trend, the system calls the actuator to change the state of the features toward a calm inducive state. Our observation of the preliminary test highlights that the emotional arousal level of the stress-inducing virtual environment is averagely higher than the stress-reducing virtual environment. However, we are not able to see the expected results for the morphing scenario. It could be because we conducted tests on a few participants. Also, through verbal feedback, we found that the morphing transition seems odd to participants. Thus, the element of surprise associated with this oddness can influence the expected result. To recap, our project investigates how to create an adaptive virtual environment that is self-regulating toward a predefined goal by employing concepts from cybernetics and adaptive systems. We have designed a virtual environment that has parameterized architectural features that can be controlled through a feedback loop dynamically. The subject or observer is a part of this self-regulating system since we feedback its real-time emotional reactions to the system by utilizing a biosensor. The findings suggest that our VR setup can manipulate the emotional arousal level measured via JSR signal. However, to establish the application of the system, more tests are needed. For more information about this project, you can take a look at our paper. Also, you can visit Dara Digital website. Thank you for your time and attention.